Okay, we're just going to learn how to graph quadratics using transformations. But first off, I want to talk about what a quadratic is. So if you look at this picture, we also call a quadratic a parabola. That's the name of the shape. It looks like a U. Some examples here are on the right, and if you look at them, what makes them a quadratic is that you have x being squared. So if we look at example 2, you can also find an x squared in there, right? We have a plane x, but we also have an x squared, so it's a parabola. Same with example 3. We have that x squared that makes it a quadratic. Now, if you look at example 4, notice there's no x squared. But if you look, they're multiplying. So if we were to distribute, we'd get x times x, giving us an x squared. So we would also have an x squared there. So that's how you can identify if it's a quadratic. So we're going to fill out this table real quick and just figure out why it's U-shaped. So if I just plug some x values in here real quick, I'm just going to plug this x value into the equation. So I'm going to take negative 2, and I'm going to square it to get 4. And I'm just going to do that same thing. So negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So now I'm just going to take these points that I used and plot them on the graph. So I go negative 2, 4, that's this point, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Now if I want to finish and make it symmetric, I'm actually going to add a negative 3 on here as well. And when you take negative 3 and square it, we're going to get a positive 9. So we've got negative 3 up 9, which makes this nice U-shaped graph. Okay, so the reason we're doing this is to find the pattern in the output. Okay, output is the y values, right, or f of x values in this case. So if we look at the pattern in the output, let's look at the difference. So if I'm looking at my table, the difference between 4 and 1 is 3. The difference between 1 and 0 is 1. Difference between 0 and 1 is 1. Difference between 1 and 4 is 3. And the difference between 4 and 9 is 5. So I found the pattern in the table. Now let's go ahead and take a look at the graph. If I start at the vertex, that's this point right here, I go up 1, and then I go right 1 to get to the next point. Then from this point, I go up 3, right 1 to get to the next point. Then I'm going to go up 5, right 1 to get to that next point. So if you notice, this pattern, this 1, 3, 5 pattern that we saw in the table shows up here as well in our vertical direction. Okay, so the pattern in the output that we're looking for is 1, 3, 5. And if you can't guess what comes next, it's going to be 7, 9, and so on and so forth. So that's the pattern a parabola has, which we're going to use to graph this next parabola. So if we look, we got to find the vertex. The x value of the vertex is always this number inside parentheses by the x. If it's inside, it's opposite. So notice it's a negative 2. The x value of the vertex is actually going to be a positive 2. The y value of the vertex comes from this 4 outside. It stays the same. So the vertex is at 2, 4. So I can go ahead and plot the vertex. I'm going to just use the pattern, that 1, 3, 5 pattern, to go ahead and graph this. But first I just got to check the rate, or the a. I guess you could say we're looking for a, which in this equation is 1. The number out front is 1. So our pattern is going to stay the same. If the rate is 1, the pattern won't change. So all we're going to do is go up 1 over 1. Then we're going to go up 3 over 1, and then we're going to go up 5 over 1 in both directions. So that's how this pattern works. So if we start at the vertex and we go up 1 over 1, then from that point I go up 3 over 1. Then I start at the vertex again and I'm going to go up 1 and left 1. Then up 3, left 1. So you're going to go over in both directions to create this U-shaped graph. All right, I'm going to try this one again. I just got to find the vertex. Number inside by the x is the x value of the vertex. If it's inside, it's opposite, so we've got a 2 here. This is the y value of the vertex, so that's where we're going to start. We go right 2, up 4, plot a point for our vertex. Again, it's a parabola because I see the x is being squared, so I'm going to use that 1, 3, 5 pattern. And this time, the rate is 1/2, the number out front. So what we're going to do is take the pattern, the 1, 3, 5 pattern, and we're going to times it by the rate. So I'm going to take 1 and times it by 1/2, take 3 and times it by 1/2, and take 5 and multiply it by 1/2. That is going to give me a new pattern, is what I like to call it. So 1 times 1/2 just gives us 1/2. 3 times 1/2 gives us 3/2. And 5 times 1/2 is 5/2. So this is our new pattern that we're going to use. So we just use that 1, 3, 5 pattern and the a in front of the equation to get our new pattern. So what we're going to do now is we're still going to go up 1/2 over 1. Up 3/2 over 1. And up 5/2 over 1. Notice we only ever go over 1. That's never going to change. The only thing that will change is our vertical pattern. So from the vertex, I'm going to go up 1/2 over 1 in both directions and plot a point. Then from those points, I'm going to go up 3/2. So there's 1/2, 2/2, 3/2 over 1. Then from there, I'm going to go up 5/2. 1/2, 2/2, 3/2, 4/2, 5/2 over 1. So there's that side of the parabola. From this next point, I'm just going to complete the left side. So I'm going to go up 3/2 over 1, up 5/2 over 1, and now you can see we have this parabola. Okay. All right, new problem. I know it's a parabola because I see that the x is being squared. Now notice there's not a number inside parentheses by the x. So the x value of our vertex is going to be 0. The y value of our vertex is that 2 that's outside. So we're going to go left and right 0, up 2, plot a point for our vertex. The rate, or a, equals 1, but in this case it's a -1. So what this negative does is it works just like with absolute values. That negative is going to make it open down. So that's why we have this question here, is open up or down. So we're still going to use that 1, 3, 5 pattern, but instead of going up 1 over 1, we're actually going to go down 1 over 1, down 3 over 1, down 5 over 1. So start at the vertex and just go down 1 over 1 in both directions. And then from that point, go down 3 over 1 in both directions, and down 1, 2, 3, 4, 5 over 1 in both directions. And you have this parabola. All right, here's a new one. Vertex. X value of the vertex is the number inside by the x. If it's inside, it's opposite. So it's going to be a -1. This is the y value of our vertex. It stays the same. So our vertex is at -1, -2. That's where we're going to start. Pattern for a parabola is always 1, 3, 5. But the rate in this problem is 2. So again, we're just going to take the pattern and times it by the rate, as we did it 2 examples ago. That's going to give us our new pattern, which is 2, 6, 10. So same concept. I'm just going to go up 2 over 1, up 6 over 1, and then up 10 over 1. So start at the vertex, and from the vertex, go up 2 over 1 and plot a point in both directions. Then from there, go up 1, 2, 3, 4, 5, 6, over 1 in both directions, and that looks like all that's going to fit on this graph. Connect your points, make sure you draw arrows so you know that the parabola keeps going, and that's how you graph a parabola from from vertex form using transformations.